Alrighty, today because we're in various stages, I wanted to kind of individualize things, let you correct some things on your own, and just talk a little bit more about rational numbers. Okay, now you've been seeing fractions for quite a while. We need to get kind of this common understanding that a rational number means any number that can be written as a fraction where your numerator and your denominator, and I'm going to use variables a and b, that both of these numbers are integers. And what I mean by integers is it can be anything out of this list, 0, 1, 2, 3, and so on. But also it can be negative, any of the opposites of these whole numbers. Okay? The only exception is this denominator, because remember that it is not legal to divide by 0. So our big exception is that b can't be 0, because that's not in our real number system. So anytime you can write a fraction, it's considered rational. Then we said, well, sometimes we don't always leave them as a fraction. Sometimes you can turn them into a decimal as well. And when we do that, it turns out that the decimal always repeats or it terminates depending on what kind of fraction you've got. So when you look at 3/5 and you do the long division, 3 divided by 5, you should get 6/10, which is a terminating decimal because it stops. Number 2, that one was pretty straightforward. That also terminates. 4/12, that turns into 0.3 repeating. Now I'm going to start to be picky on your notation. Use the repeating bar when that digit first shows up. So don't write it this way, 0.333, and then put the repeating bar after the third time. Put it right where it starts, right there. This one is a repeater. Okay, 25/99. This one was kind of cool. When you went and did this one, you should see that this ended up being 0.252525, and it's a repeating one. I'm going to abbreviate a little bit. 7/9. This one was cool too. You get 0.7 repeating. 9/25. Now you can do the long division, but some of you had mentioned last week that you know that 25 goes exactly into 100, and that means you get 36 hundredths, so it's perfectly 0.36, and it terminates. Same thing here. Be careful with your zeros, though. It should be 0.04. It's the same as 4 hundredths, and that terminates. This one we did together in class because it was a little more ugly. 25 176ths. I'm trying to remember here what happened. It started out as like a 0.1420, 0.142045, 4, 5, 4, and then it keeps going. So I think that it repeats in this pattern somehow. Okay, that one is a repeating one. It's icky. 12 thousandths looks like this. 0.012. That one terminates. All right, number 10. 11. Put that in front and then just deal with the 1/6. And you get 1, and then just the 6 repeats. Watch your notation. 2 and 9/10 stops right there. 8 and 23 hundredths stops right there. 7 and 3/15. You might notice that 3/15 is not in simplest form. That fraction in simplest form is really 1/5, which is the same as 2/10 or 0.2. Don't forget the whole number that's in front of your decimal. 54 and 3/11. So you can put the 54 in front of the decimal and then convert 3/11. You have to take 3 divided by 11. And what you should notice is that you get the digits 2, 7 that keep repeating. That's a 2-digit repeating block. Last but not least, when you do 3 and 1/18th, you have to come over here and take 1 divided by 18. And you'll notice in that first spot, you're going to get a 0. And here's what happens with that decimal. You start using 5s, and then you see what happens. You get 0, 5, 5, 5, 5, and then that repeats. Okay? Goes to that. All right, now we get into some of these word problems. Okay? She bought 3 2/3 pounds of apples. They go on and talk about pie, but in all honesty, all of that words is simply asking you to convert this mixed fraction or mixed number into a decimal. So take 2/3, which you might remember is one of the famous ones, is 0.6 repeating. Okay, we should probably still label this as pounds for this particular question. 12 7/8 is 12 point something. Come off to the side and take 7 divided by 8. Okay, and when you start putting that in, you should get 0.875, and that one stops. This is also in pounds, and usually we abbreviate pounds that way. 18 is an interesting question, and I think we talked about this in class because I went and took a look at this one and started to do the long division. Tom was persisting and got this far, and he stopped, and it just didn't seem like this thing was ever going to stop. So he said it's not rational. What do you think? I'll let you think about that one. We'll talk about it in class. It's a good one. All right, this last chunk here, basically you're writing a bunch of ratios. Remember that a ratio means comparing two numbers, and oftentimes we write it as a fraction. So basketball is 5 to football, which is 11. So first write the ratio, then as a decimal. This guy is going to end up being, I believe, 0.45 repeating, and that is a repeating decimal. Hockey to lacrosse, 6 to 10. 6/10. Oh, nice. That one is a terminating decimal. Polo to football. Polo to football is 4/11. When I convert that one and do the long division, 4 divided by 11, okay, you should get 3, 6, 3, 6, 3, 6. That is a repeating one. Lacrosse to rugby. Lacrosse is 10 and rugby is 15. Say if you notice this thing is not in simplest form, I would go ahead and put it in simplest form. This is the same as 2/3, and you might have that one memorized because it's kind of common at 0.6 repeating. Finally, we have football to soccer. Oh, look at that. 11 to 11, that's 1. How do you write that as a decimal? I put a decimal point right there. That's a terminating one. Okay, it doesn't have anything that repeats. All right, 24. Beth said that the ratio of the number of players in any sport to the number of players on a lacrosse team must always be a terminating decimal. Why or why not? Let's take a look. If lacrosse is the denominator and it's in tenths, then guess what? Tenths is your first decimal place. So I would agree because tenths is the first decimal place. It will always be a nice decimal that terminates, is the first decimal place. Good. Period. Yvonne bought material. Okay. She bought 4 7/8. First, they want it written as an improper fraction. So remember how to do that. Take the whole number times the denominator, because this is like saying you have 4 whole pizzas and then 7/8 of another one. Okay. So all of these, okay, and then all but one of these. So this is the 7/8. These are each 8/8, 8/8, 8/8, 8/8. That's 32 plus 7 more. 32 plus 7 more. 39/8. As a decimal, you can leave the whole number out front, and then 7/8 is 0.875. The last one, so if she wanted to make 3, explain how she could use estimation to make sure she has enough. Well, 4 and 7/8 is almost 5. Almost 5. And since we're talking about yards, I'm going to say, well, that's almost 5 yards. 3 dresses times 5 yards apiece would be 15 yards. Okay, so she could estimate 15 yards, and she should have enough if she is using 4 and 7/8 for each one. She could estimate 15. There you go. All right, some of these last ones here. Here's what I'm going to tell you, okay? I would like you, if you are struggling with some of these, we'll talk a little bit more, but I want you to think and work on these yourself. In addition, on here, this is a good question. I like that one. Actually, all the rest of these are good. So I think here's what I'm going to do today. I want you, if you didn't finish all the way through these guys, do basically everything on page 66. Finish that up, okay? And then look on the whiteboard and see if I've got anything else assigned for you for today. All right? This way we get a chance to do all this work, and yet some people are still finishing some tests. So good luck, and may the force be with you.